Hello everyone, my name is Adrian Nugroho Basuki from Bina Nusantara International University, and I'll be the speaker for this presentation. So today, I'll be discussing our paper titled Utilizing Machine Learning for the Classification of Tweets as Human or Bot Generated, which was accepted as the 33rd submission. And in this presentation, I'll walk you through the background of our research, the data collection process, the dataset preprocessing, the machine learning models we use, as well as the evaluation metrics, our results, and finally, the conclusion and our possible future works. So starting off with the background, so in today's world, in every social media platform out there, there are a large amount of bot activity. Even though these bots could be used for positive purposes, it could also be misused to do harmful purposes, such as spreading malicious links or misinformation. And these bots may include hacked or sold real accounts, so accounts that a human once owned. This makes it so that the profile-based bot detection is unreliable because the profile may be still using the user's profile, though that the person bought the account from. So therefore, we decided that a more in-depth analysis of the tweet content itself is required to accurately differentiate between the human and bot-generated activity. So next, here's our data collection process. We use a tool called Tweet Harvest. So we feed it the search keyword and a date range, as well as the file name we want to save it to. It's an open source tool available on GitHub. We can just clone it or use it using Google Colab. And we actually tried using two different other tools, but it didn't work out because first we tried Twitter API and it was heavily limited, so we barely could get any results. And for better results, we required payment. And other than that, we also tried using an online bot detector called Botometer. It's an existing one. And however, sadly, its data is outdated, so it stops at around 2023. So using this tweet harvest tool, we collected tweets using several keywords commonly used by bots and humans. And after that, the output will be CSV files with the columns such as tweet hashtags, favorite counts, quote counts, reply counts, and the retweet counts. These are the default columns from the tweet harvest tool itself. And once we have finished collecting our data, we ended up with many folders containing bot and human CSV files. Of course, they are separated into human and bot folders from different time ranges and using different keywords for each time range. So here's a snippet of the scrape data for the human data. As you can see, there's a lot of variance. It's not repeated. And here's the scrape data for the bot data. As you can see, there's a lot of repeating, like all of the tweets contain the same message. And this is only for one keyword. There's many other keywords that show this type of data. So next, let's move on to dataset preprocessing. Our first step would be merging all of the bot and human CSVs and adding the label column, marking it as bot or humans. And after that, we will end up with two large datasets one for human and one for bots. And once we have those two datasets, for each of them, we'll flag possible misclassified data. So if there's a human data in the bot CSV or vice versa, we will flag it by changing the label column for that row. So after that, we merge both bot and human dataset into one large dataset, which will be fed into the Google Colab to be cleaned. And then we add No, before we add features, we clean it by filling the empty cells with none or unknown, removing outliers, and removing characters such as tabs and new lines, because that may interfere with the identification process. So next is feature engineering. We're adding more features based on the existing ones, such as checking if the tweet has links. That could be one new column. And lastly, we would do standard scaling, standardization, by using sklearn standard scaler. So here are the 6 machine learning models that we used. It produced the best results. Uh, First, we have SVM using the RBF kernel. Next, we have XGBoost, random forest, decision trees, logistic regression, and k-nearest neighbors, or KNN. Now we'll be moving on to the evaluation metrics. So first we have precision, which is the accuracy of true positives, as you can see. I've also provided the formula, which is true positives over the total of true positives and false positives. Next is the recall, which measures how well a model identifies positive instances in datasets. The formula is true positives over the total of true false positives and false negatives. And lastly, from this list is F1 score, which is the harmonic mean of precision and recall. There's still 4 other evaluation metrics that we use. First one among these 4 would be accuracy, which is the ratio of correct predictions to the total predictions. Then we have weighted average, which is the precision, recall, or F1 score, averaged by the class instance counts. Next, we have macro average, unweighted average of precision, recall, or F1 scores across the classes. And lastly is a confusion matrix, which is a table of predicted versus the actual values. There are 4 outcomes: the true positives, false positives, true negatives, and false negatives. Next, here are our results. This is the first 3 machine learning models, starting with the SVM using the RBF kernel. We have the confusion matrix, precision, recall, and F1 score, as well as the accuracy. And we can see that the accuracy is 92.55%. And next, moving on to the XGBoost with the same evaluation metrics, but a higher accuracy score. And next, we also have decision tree, being the lowest accuracy score among these 3. Here are the remaining machine learning models that we used: the k-nearest neighbors, random forest, and logistic regression. And among these 3, the highest accuracy being random forest and the lowest being logistic regression. And aside from the results for our machine learning models, for the accuracy and other scores, we also tested the feature importance analysis using MDI, or mean decrease in impurity, which computes the reduction in impurity contributed by all splits for a certain feature in the decision tree. So it only applies for the decision tree based machine learning models. And a higher MDI value indicates that the feature contributes more in improving the decision-making process of the machine learning model. And as you can see here, the text has link feature is by far has the highest mean decrease in impurity score, which means that it's the largest contributor to the decision-making process, whether the tweet is generated by a human or by a bot. So, okay, let's conclude this presentation. So based on our research, we found that XGBoost, random forest, and k-nearest neighbors are the most effective models achieving the highest accuracies and F1 scores. As for the tree-based algorithms that are tested, text has link contributes the most to reducing the impurity. And here are some improvements that we can make for our future work. Scrape more bot data because our data has data set has more human data compared to bot data, so it's a bit imbalanced. And after that, we can also further analyze tweet text structure to compare language patterns between humans and bots by doing sentiment analysis using NLP, maybe. And yeah, that's it for my presentation. Thank you for paying attention.